Hello! Yes, and welcome back to our Objective 11 notes. We're going to finish these up today. Objective 11, remember, is I can find the slope of a linear function and understand it as the rate of change. So what we're going to do today, just to give a quick review, remember that slope, the rate of change, we talked about telling if it's a positive or negative slope. We talked about all the different ways you can write slope and all the different ways it's said. We talked about finding the slope graphically, and then we also talked about finding the slope algebraically between 2 points, and then we checked that graphically. We did a lot of those. We're going to have to do those a bunch. We also talked about, remember, that a horizontal line has a slope of 0, a vertical line has an undefined slope. Then we talked about finding slope from a table. We looked at if that table was had equal steps from x and how easy it was to see then, and then what if it didn't and we had to use points again. And now today we're going to talk about applications of some slope. So let's start with this first example here. The graph below shows the distance John biked over the course of 6 hours. At what speed was John biking? All right, so we're going to assume that this is our distance, and this would be hours. Okay, so at what speed was John biking? Well, oh goodness, how could I determine that? Well, the distance they travel, right here. All right, so in 6 hours, he went all the way up to here, which looks to be, according to this, 6,54. Now I'm looking for other points that seem to look pretty nice. Yep, right here. This would be 4,36. And then we would have here 2,18. Excellent. All right, so at what speed was John biking? Well, speed in this sense would be represented by the slope of this line. So let's use these 2 points here to find the slope. So we'll say this is x1 and y1. We'll say this is x2 and y2. So m would equal y2, 36, minus y1, 18, over x2, 4, minus x1, 2. 36 minus 18 is 18. 4 minus 2 is 2. So we find that m equals 9. And that 9 would be represented by 9 miles per hour. So John was biking 9 miles per hour in this rate. How far did John travel in 3 hours? What coordinate point shows this? Well, if he went 9 miles per hour in 3 hours, we have this coordinate point here, and 3 times 9 would be 27, which sure enough is that coordinate. So 27 miles, and that's shown by the coordinate point 3, 27. How far did John travel in 6 hours? Well, we actually already found that one. In 6 hours, he traveled 54 miles. That coordinate point shows that. Oh, goodness, 54 miles. Use the graph to show the distance John would travel if he went 2 miles per hour slower. Okay, so instead of going 9, he's going 7. All right, so that would mean he was moving 7 miles per hour. And we're going to graph this here. Let's see. Let's switch up our color here so we don't get confused. So, oh, that's really big. Let's make it a little smaller. There we go. Let's put you right here. So 7 would be right there. Then 2 times 7 would be 14. 3 times 7 is 21. 4 times 7 is 28. 5 times 7 is 35. That'd be right in the middle there. And 6 times 7 is 42. So there are the points of that line. Now, obviously I would need to connect my dots here, so I'm going to go ahead and do that. There we go. That would be the slope. That would be the graph if John traveled 2 miles per hour slower. So he would have only gone 42 as opposed to 54 miles in that case. Excellent. All right, let's look at letter B together as well. All right. Let's see. The table below shows the amount of water filled into a man-made lake over the course of 12 hours. Okay, what's the rate at which the water is being added to the lake? All right, rate would just be another word for slope, of course. So let's use a couple of these points to figure it out. So we got 2, 282, and we have 4, 504. All right, very nice. So we have x1, y1, we have x2, y2. We would say that m equals 504 minus 282 over 4 minus 2. 504 minus 282, that might be one that's helpful with a calculator. 504 minus 282 equals 222. All right. So 222 over 2 minus 2, or 4 minus 2 would just give me 2, which would equal 111. Fantastic. All right, so how much water would you expect to be added to the lake if this continued for 20 hours? Okay, so if it gets 111 gallons per hour, and we do that for 20 hours, that's some multiplication that I'm not really feeling right now. So 111 times 22, let's put that in our calculator, 2,442. 2,442. Are these gallons? Yes, gallons. Fantastic. So we found that 111 gallons are added per hour, and over 20 hours that would add 2,442 gallons. All right, raise your hand if you have any questions. Otherwise, I would like you to go ahead and try letter C on your own. Go ahead and try letter C on your own, and then we will check it together. Go ahead and pause the video, try letter C, and then we'll check it together. All right, let's look at this one. Kim is wanting to keep track of the distance her train has traveled after passing through Lawrence on its way to Chicago. She knows the train is traveling at 60 miles per hour. Okay, that's some important information. If it is 450 miles from Lawrence to Chicago, so that's the total distance we need to travel, the train has no more stops. About how long of a train ride should it be? Use the graph provided to support your argument. All right, so I'm going to zoom out a little bit here so we can see the whole graph. 60 miles per hour for 450 miles. So we'll assume that these are our miles, these are our hours. So at 450, which would be right here, that's when she should be arriving in Chicago. So we want to know when our line is going to pass that dash line. Now our line is obviously going to start at 0, 0, because after no time she's traveled no distance. But after 1 mile, or after 1 hour, she's traveled 60, which would be the point right here. After 2, she's traveled 120. After 3, she's traveled 180. 4 would have been 240. 5 would be 300. 6 would be 360. 7 would be 420. And 8 would be 480, which would actually be off the graph, but above that line. All right, that was our goal, right? To figure out where that line would hit. So let's connect our dots here. So this line has a slope of 60, and we want to know where it crosses this line. Where it looks like, if this is 7, it looks like this is going to come down and touch at 7.5 hours. So we would say 7.5 hours until Chicago. How exciting. Very good, very good. All right. Raise your hand if you have any questions on that one. Otherwise, why don't you go ahead and try letter D on your own. Got some algebra. No graph here, just looking like we're looking at slopes. Go ahead and try D on your own, pause the video, and then we will check it together. All right, so let's see how we did here for letter D. The O&W Math Department purchased a high-volume copy machine for $15,000 After 8 years, the equipment will have to be replaced. Its value at that time is expected to be $3,000. Find the rate at which the value of the copy machine depreciates. Okay, so at time 0, where no time has passed, it had a value of $15,000. Time value. And then 8 years later, so that'd be the time for this one, it had a value of $3,000. All right. So those are the two coordinate points I'm going to use. We're going to say this is x1 and y1, this is x2 and y2. And I will say m equals 3,000 minus 15,000 over 8 minus 0. Well, 3,000, that'd be negative 12,000 over 8, which, on our handy-dandy calculator, negative 1,2,0,0,0 divided by 8 is negative 1,500. So, I would say m equals negative, I guess I don't need the dollar sign yet, 1,500. So what does that mean in the context of the problem? Find the rate at which the value of the copy machine depreciates. So let's give this an answer here in a sentence. Each year, the value of the machine decreases by $1,500. Excellent. All right, and that's going to conclude our notes for today. Raise your hands. Let me know if you have any questions. Happy to help. Otherwise, we're going to move on today. So work on your practice problems till everyone's done. Have a great day, and Mr. Carter signing off. I'll see you next time.